Hello and welcome to this video. Today we are going to learn how to automate operations with playbooks and runbooks using System Manager. Before we begin, let me quickly introduce myself. I am Ajit Inamdar. I work as a cloud architect with one of the leading cloud consulting companies in India. I have about 10 years of experience in the IT industry across multiple domains. I am 9x AWS certified professional. Apart from that, I am also recognized as an AWS ambassador and a community builder. Please feel free to connect with me on LinkedIn. The link is mentioned here. Let's have a look at the agenda for this video. Firstly, we will see what is AWS System Manager Automation. Then we will try to understand what are runbooks and playbooks. Then we will see what are the benefits of SSM automation. We will see who should be the actual users of this automation. And finally, we will see everything in action. Let's start with our agenda by discussing about AWS System Manager Automation. Automation is a capability of AWS System Manager. It simplifies common maintenance, deployment, and remediation tasks for AWS services like EC2, Amazon RDS, Amazon S3, and many more. Automation helps you to build automated solutions to deploy, configure, and manage AWS resources at scale. That means you can implement automation across tens and thousands of servers across multiple accounts. With automation, you have granular control over the concurrency of your automations. This means you can specify how many resources to target concurrently and how many errors can occur before an automation is stopped. Automation will help you to execute multiple commands over multiple resources at once. This is a sample SSM automation architecture diagram. We can execute the automation via AWS SDK, Management Console, or via the command line interface. Apart from that, we can also schedule execution of the automation via Amazon CloudWatch events. Once the automation is triggered, it will check for permissions and the trusted entities for the IAM role passed while executing the automation. It will check the automation documents, that is your runbooks and playbooks. Based on the steps mentioned in the document, it will trigger API, Lambda function, script, or the run command, or combination of these actions, and it will run automation across EC2 instances, RDS or S3 buckets, and many more services as per the requirement. Now let's understand what runbooks and playbooks are in general IT terms. A runbook is a set of instructions for completing a routine task, for example, taking regular AMI backups and RDS backups. A playbook is more general document outlining the organization's approach and worker responsibilities. An example of a playbook can be installation and configuration of a complete LAMP stack. So these are some of the sample use cases for runbooks. Runbooks can be used to perform routine operations like patching, starting and stopping a server, and taking regular backups. It can be helpful for emergency operations as well, like failing over to a DR site or rebooting an EC2 instance. Runbooks are also used to deploy infrastructure using CloudFormation templates. Some of the use cases of playbooks are application deployment, that is, we can install and configure a complete LAMP stack on AWS using playbook automation. Another use case can be implementing in the security domain, where you can implement infrastructure monitoring and vulnerability management as a part of a single playbook. We have seen what is automation, runbooks, and playbooks. Now let's move on to the benefits of automation. Using SSM, you can run automations across multiple AWS accounts and AWS regions from a centralized location. For instance, most of the organizations have a centralized shared services account from where they control the entire AWS ecosystem. Using SSM, your operations security get enhanced. Administrators have a centralized place to grant and revoke accesses to runbooks, and automating common tasks can help you improve operational efficiency, enforce organization standards, and reduce operational errors. Automation provides predefined runbooks that streamline complex and time consuming tasks such as creating golden Amazon machine images or the AMIs. We can implement scripts in the runbook content for our custom requirements. Using the AWS execute script action, you can run custom Python and PowerShell functions directly from your runbooks. Safely perform disruptive tasks. Automation includes features like rate controls that allow you to control the deployment of an automation across your fleet by specifying a concurrency value and an errors threshold. This helps in performing disruptive tasks with caution. You can define the best practices for resource management, operations tasks, and more in runbooks that you can share across regions and accounts. Automation helps you to avoid downtime and human errors. We have seen the benefits of automation. Now let's see who should use this automation. Automation can be used by the customers who want to improve their operational efficiency at scale, reduce errors associated with manual intervention, reduce time to resolution of common issues. Infrastructure experts who want to automate deployment and several configuration tasks. Admins who wants to resolve common issues, improve troubleshooting efficiency, and reduce monotonous and repetitive operations. And anyone who want to automate tasks that are normally performed manually. We have seen everything in theory. Now let's understand a sample runbook in action. We are going to see the following use cases in today's demo. The first use case is to execute a custom document to create an AMI and copy to some other region. The second use case is to execute a custom document to restore a root volume from a latest snapshot. And finally, we will see how to restart an instance using automation document provided by AWS. These are the steps involved to automate the AMI creation and copying across a different region. The create image step, verify image availability step, and finally copy the image step. So let's go to the AWS documentation. This SSM runbook performs the following action. Execute AWS API to create an AMI. Wait for AWS resource property to confirm the availability. And AWS execute script to perform the copy. Let's look at the contents of the YAML document. We are going to use the role which is being passed as an input parameter. So we have the following parameters: automation assume role and instance ID. So these are the main steps. The first one is to create the image. The action is execute AWS API. The API is create image. And we will keep the no reboot as false. The output of this step will be the new image ID which will be used in the later steps. The next step is verify image availability. The API which is going to execute is describe images. We are going to pass the input as new image ID which was taken from step number 1, that is create image. The last step would be copy image. The action would be execute script, which will be a Python 3.6 script to copy the image from source region to destination region. Now let's switch to the AWS console. Our source region would be Ohio and the destination region would be North Virginia. For this demo, let's quickly create a new EC2 instance from the EC2 console. Go to launch instance. I'm giving the name as SSM automation demo. Let's create a new key pair SSH automation demo. I'll keep all other settings as default and click on launch instance. We can see that the instance is created successfully. Let's wait for the instance to get into running state. Meanwhile, let's go to the IAM to create the automation role. Choose roles, create role. Under the use case, select Systems Manager and choose Next. Under the Add Permissions section, for this demo, I am selecting Amazon EC2 Full Access and choose Next. Enter a role name of your choice. I am adding SSM Automation role for EC2. Quickly verify the permissions and trusted entities and choose Create Role. Let's validate whether the role is created as per our requirement. Go to the EC2 console and check whether our instance is in the running state. Once confirmed, let's go to the System Manager and choose Automation. Click on Execute Automation, create document and enter the name as Create AMI and copy to different region. Go to the editor and click Edit. From the AWS documentation, copy the custom YAML document and paste it in the document editor. Here we see three steps. First is the create image. Verify image availability and the copy image. I will change the source region to US East 2 as per my requirement. You can see that the document was created successfully. You will see your custom document under the Owned by Me tab. Choose your document and click on Next. Under the input parameters, select the IAM role you have created previously. And under Instance ID, copy the instance ID from the EC2 console. And choose Execute. You can see here that the execution has been initiated. Under the executed steps, you can see the three steps mentioned in the document, that is create image, verify image availability and copy image. Create image is completed. Let's wait for the others to complete. Meantime, it is validating. Let's check whether the image is created as expected. So the verification is complete and the copy image step is underway. It took 4 minutes for image creation and verification. The final step, that is copy image, is also done. Let's quickly switch the region and validate whether the image is copied. Here we can see that the image is successfully copied. This completes our use case number 1. Now let's move to the second use case, that is restore a root volume from the latest snapshot. For that, these are the following steps required. Get instance details, get root volume ID, get snapshots by start time, branch from results, create new root volume from snapshot, stop instance, verify volume availability, verify instance stopped, detach root volume, and finally verify the root volume that is detached. Let's go to the AWS documentation and have a look at the custom document for our requirement. This runbook performs 3 actions, that is the AWS execute AWS API, AWS execute script, and a branch automation action. Let's see the steps one by one. Get instance details, get root volume ID, get snapshots by start time, branch from results, create new root volume from snapshot, stop instance, verify volume availability, verify instance stopped, detach root volume, and finally verify the root volume detached. Let's go to the AWS console, choose IAM. Under roles, we are going to reuse the automation role created in the previous automation. Now let's browse to EC2, click on instances, go to the snapshots. Here we can see we already have a snapshot created during our previous automation for AMI. We can reuse this for the snapshot restoration as well. Now let's go to the Systems Manager. Choose Automation. Execute Automation. Create Document. Enter the name Restore a root volume from latest snapshot. Choose Editor. From the AWS documentation, copy the YAML script, click on Edit and paste it here. Quickly validate everything that has been copied as required. And choose Create Automation. Visit the Owned by Me tab, choose the document we just created and choose Execute Automation. Enter the automation role we have created in the use case number 1. Copy the instance ID from the EC2 console. And choose Execute. Here we will see a list of steps we had earlier seen in the YAML document. Let's wait for everything to complete. We can see that the instance is getting stopped. So the status for all steps is now success. Let's quickly validate the instance is getting started. If you go to the instance and then storage tab, you will see one volume is attached. Let's click on that. Under the snapshot section, you will see that it has been created using a snapshot. Go to the snapshot section, you can see that it is the same ID. So the snapshot restoration is successful. In the volume section, you will see two volumes. One is available and the other is in use, which was taken from the snapshot. This completes our use case number 2, that is restore a root volume from the latest snapshot. Let's see our final use case, that is restarting an EC2 instance using automation. This automation will have two steps, that is stop instance and start instance. Go to Systems Manager, Automation, Execute Automation. In the search box, type restart. Choose AWS Restart EC2 instance. Choose Next. I'll choose the automation role created in the use case number 1. Choose Show All Instances. Select the SSM Automation Demo instance and choose Execute. In the executed steps, we can see stop instances and start instances steps. In the EC2 console, we can see that the instance is getting stopped. After waiting for some time, the status for stop instance is success and the instance start is in progress. After waiting for some more time, the second step has also succeeded. This way, we have completed our third automation, that is restart of EC2 instances. Thanks for watching. Please watch out this space for more such informative content.